Welcome to section 5.5 of College Algebra. I'm Gregory Carlson. In this chapter, we've solved 2 by 2 system of equations where we had 2 lines. We also solved a system of 3 equations with 3 variables, which were represented by 3 planes all intersecting each other. So what comes next? Well, we could use a matrix to solve a higher and higher order system, but what we'll do instead is actually take a look at this. We can actually solve systems of nonlinear equations. And you notice, for example, in this picture, we have a line intersecting a parabola. And the question is, where do these intersect? Luckily, we don't really need to learn any new math to do this. All you need is substitution and elimination, which we've already covered. And so you'll notice that here I've got this system of equations, and they're nonlinear because this one is a parabola, and they're represented by this graph down here. A solution is where the two curves intersect, because as a reminder, the curve represents all of the solutions to one of these. And so therefore, when they intersect, that must be a solution for both of them. And so we can see from this graph that the solutions are negative 2, 5 for that point, and 4, 17 for that point right there. Now, those are based on the graph are the two solutions. And so let's go ahead and check one of them. And remember that you need to check them for both equations. So let's try negative 2, 5. If I plug in negative 2 for x, that squared is 4. And if I plug in a 5 for y, I get 5 minus 1, which is also 4. So 4 equals 4. So this satisfies the top equation. Now let's plug it into this equation. Plug in negative 2 for, let's start by plugging in 5 for y. Plug in negative 2 for x. Again, make sure you don't mix those up. 2 times negative 2 would be negative 4. And negative 4 plus 9 is 5. So you get 5 equals 5. And so this is a solution for both of them. And you can also check 417 for both of them, which is also a solution. So it's nice and easy when we have the graph and they tell us where they cross. But what happens if we don't have a graph and we just have the system of equations? And luckily, all we need is just substitution and elimination, which we've already learned. The only catch is you always want to check all of your answers because every now and then substitution and elimination can produce an answer that doesn't actually fit both graphs. So in looking at this, I think the easiest thing to do would be to use elimination because the negative y and the y will cancel if we add the equations together. So let's do that. Let's add them together. Now don't combine x squared and 3x. Those are not like terms, so don't try to add them together into one term or anything. So we got x squared plus 3x, the y's cancel, is equal to 10. Next, we can move the 10 over, giving us x squared plus 3x minus 10 is equal to 0. From here, you could go straight to the quadratic formula to solve for x. However, I noticed that this factors, so let's factor it. That gives us x plus 5, x minus 2 is equal to 0. So let's check that. I noticed that 5x minus 2x is 3x, and 5 times negative 2 is negative 10. So that works, and because of the zero factor property, we have solutions for negative 5, and we have solutions for 2. All right, so there's two x solutions. Let's solve for y, and let's do that by plugging into the top equation. So if I plug in negative 5 for x into the top equation, I start by getting negative 5 squared minus y equals 0. So that's nice, so let's solve that. Negative 5 squared is 25. And if we add y to both sides, we get 25 equals y. So it looks like our first point is negative 5 comma 25 as x and y. But before we put that in stone, let's just check to make sure it works in the other equation. If I put in a negative 5, well actually let's find the other one first. So let's plug in 2 in there. So I have 2 squared minus y equals 0. Square the 2 and we get 4. And if we add the y over, we get 4 is equal to y. Oh, I'm actually not going to box that. So 4 equals y, so it looks like our second solution is the point 2, 4. All right, now before we put these in stone, let's make sure that we check them in our second equation. We know they work in the first one because we used the first equation to get these 2 points. But let's make sure they work in the second one. Let's check this. If I plug in 2 for y and a 2 for x and a 4 for y, I get 3 times 2 plus 4 is maybe equal to 10. 3 times 2 is 6. 6 plus 4 is indeed equal to 10, so that is a solution for both of them. Let's try negative 5, 25. So 3 times negative 5 plus the y value, which is 25, is maybe equal to 10. 3 times negative 5 is negative 15, plus 25 is indeed equal to 10. So both of those are our solutions, and we can actually be confident that those are the only 2 solutions. All right, let's try this one. And again, if you like substitution better, you could have added the y over and substituted in the x squared for y, and that would have also worked. But you know me, I tend to use elimination if at all possible. All right, let's try to solve this one really quickly. Again, this looks like a candidate to me for elimination because the x squareds, the y squareds, and the numbers are all lined up. Also, we can eliminate the x's. I have a 2 and an 8. So if I multiply the top equation by negative 4, that will give me negative 8 and 8, which will cancel. So do the distributive property on the top equation gives us negative 8x squared plus 20y squared, and negative 4 times 0 is equal to 0. On the bottom equation, it just stays the same. X squared plus 7y squared equals 0. We did not do anything to the bottom equation. Let's add these together. I add them and I get, excuse me, 27y squared equals 0. That's kind of interesting. 27y squared equals 0. Let's divide both sides by 27. Divide by 27. Y squared equals 0. And if we take the square root of both sides, there's really only one thing that y can be. Y equals positive or negative 0, but 0 doesn't have a sign. Positive 0 is the same as negative 0. So the only y answer is 0. Okay, well, let's plug in 0 for y and see what we get for x. If I plug it into the top equation, I get 2x squared minus, plug in the 0, just makes that whole thing 0. So 2x squared minus 0 equals 0, or 2x squared equals 0. And by the same logic, by dividing by 2, you're just going to get x equals 0. So that means the only point that is a solution is 0, 0. Luckily, that's an easy point to check. Obviously, 0 minus 0 is 0, and 0 plus 0 is 0, so the answer is 0, 0. And in fact, that is the only place where they intersect. Let's stop here, and in the next video, we will look at the next page and do a few more examples. See you there.